Alright, I had some people ask me, they're a little bit confused still with the problems. Just hopefully I can clear this up. This is number 3 on 6.5. So you probably should be already familiar with the problem at least. F of x is -5 square root of x. Sorry, fourth root of x. G of x is 19 fourth root of x. And for the second part, x is equal to 16. Okay, so they want you to perform f plus g of x. Okay, so what that means is I'm going to add these two together. So the fourth root of x, okay, will stay the same, but the coefficients, -5 and 19, will become a new coefficient when I add them together. So -5, okay, so -5 plus 19 is going to give me 14. So this is 14 square root of x, okay? From there, I evaluated x equal to 16, so now that I have a new function, I evaluate it at 16, so this is 14, the fourth root of 16. So what is the fourth root of 16? You can use an online calculator to find the fourth root of 16, or think to yourself, how many times should a number be multiplied to itself 4 times to give me 16? Well, we do know that 16 can be broken up as 4 times 4, and then 4 can be broken up as 2 times 2, and then 2 times 2 over here. So notice that its base root is 2 to the 4th power. So then this is going to be 14 times 2, and that should give you 28. Hopefully that helps you out with that, would give you some idea with that problem right there. So I'm going to go ahead and create a new function. For example, here, let's say I keep my f of x, g of x here. I keep it to the fourth root. I'm going to change this instead to x to the 1/4 power. Okay, and I'm going to make this 25, and I'm going to make this 5. Alright, and this is now another example here now. So let's say I want to do f divided by g, okay, of x, and again x equals 16, just to make that a little bit easier, okay? So f divided by g, I'm going to take this function and divide it by that function. So 25, the fourth root of x, divided by 5x to the 1/4, okay? This is f divided by g. Now again, remember I talked about like, hey, how do I change these formats? Okay, I can basically write this as 25x to the 1/4 divided by 5 over x to the 1/4. So x to the 1/4, x to the 1/4, they're the same. I keep it that way. Okay, and I just go ahead and I divide into itself. Actually, I'm sorry. I divide this into itself. So think about it. What do I have? So x to the 1/4 divided by x to the 1/4 is really saying this. I'm really sorry about that, guys. X to the 1/4 minus 1/4. Okay, remember that. Division means subtraction of exponents. 25 divided by 5 is just 5. So guess what happens? This is x to the 1/4 minus 1/4. That becomes 5x to the 0 power. Okay? So anything raised to the 0 power is just 1. So this whole thing becomes this. Okay? So my answer here would be just 5. And so since I don't have an x, I don't have to worry about evaluating x equal to 16. Okay? Now, let's go ahead and do one more. Let's say, for example, I keep the very same thing, but this time now I make it to the 3/4 power. So I go ahead and repeat everything again, but this time this is to the 3/4 power here. Okay? I change this to this again. Okay, I'm rewriting this. And what I'm really saying is 1/4 minus 3/4 here. Okay. Okay, so what is 1/4 minus 3/4? 1/4 minus 3/4 arithmetically is negative 2 over 4. Okay, that's negative 2 over 4. So now, what do I do with that crazy looking exponent? Okay, I'm going to take this whole thing, I'm going to bring it over here. This is still f of g equals 2. Now I can reduce that fraction as negative 1/2. Okay? So 2 goes into 2 one time, 2 goes into 4 two times, right? Now you can remember that. And now what I really have is 5, the square root of x. Now, since this is negative, I'm writing it over 1, okay? So here, just to help you out with this, that's what I'm writing it as, okay? So this whole thing becomes this. I hope this kind of helps you out with different types of examples, okay? So now, going back up to here, what is x equal to? 16. So this is 5 times 1 divided by 16, the square root of 16. We all know that that's going to be 5 times 1/4. Okay? So therefore, this will be 5 divided by 4. And that will be my answer for that. Okay? So that's 3 examples working with division, addition, there. Now, if we move further on, let's take a look at 7.2. Now 7.2 is going to use a lot of the exponent arithmetic that we just did over here. So for example, let's see here, looking at the work. So for example, simplify. Let's take a look at number 2. This is 7.2. Okay, 7.2. I do 24e to the 8th power divided by 8e to the 5th power. Okay, this is number 2 on your practice work. Okay. Now, if I take a look at just this part, 24 divided by 8. Everyone knows how to do that, right? So 24 divided by 8 is going to be just 3. Now, you see there's 2 e's, right? E in the top, E in the bottom. They're just like x. Since these are the same base, I can write the e again. The exponent 8 over 5 is really saying 8 minus 5. So what's 8 minus 5? Well, 3e to the 3rd power. And that's what that really is. Okay? And that's my answer for that. That's all you really have to do with that. Now, on the graphs, you're seeing something. You're seeing a graph. One graph style looks like this. Okay? That's one graph. The other graph looks like this. Okay? Those are 2 graphs. What determines that graph behavior? That's all I was asking you to do with that. So for example, which one of those graphs, 23, I gave you a hint. 23, I believe 24 and 25 were graphed this way. 23 and 26. Number 23 and 26 are graphed this way. Numbers 24 and 25 are graphed this way. Why is 24 and 25 graphed this way? Why is it graphed that way? The hint is in the exponent, okay? So the hint is like, is it positive, negative? Is it a big number, small number? I don't know. Which one is it? That's what's going to kind of give you the hint. It's about it's the self-discovery there, okay? So hopefully that helps you out. The notes I gave you with 7.2, okay, deal with how the natural base E came about. So you're just working with it. You don't have to discover anything crazy about it. E is a constant number. That the way the graph, okay, looks like this. When I have e raised to any value, okay, all right, it's going to curve like this and cross at a certain point on the y-axis. Okay, so for example, this is let's say this was e to the x plus 2. So then when this is at 0 here, then I put 0 into x. Any number raised to 0 power is 1. 1 plus that 2 will give me 3. So it crosses the y-axis at 3, and this is how the shape looks like, for example, okay? So that's just the introduction. That's all I wanted you to do with that. And I believe that pretty much, hopefully that helps answer some of the questions that some people had about this. Let's see here. Oh yes. Going back to 6.5, I had mentioned something about what is the domain. So the domain of the function, I gave you a hint that says it either starts at 0 or goes from negative infinity and it's going to end up at positive infinity, okay? So no matter what, the domain, going back to 6.5, and if we go back to number 3 again, and we did f plus g of x, let's use that function, we got 14 fourth root of x, okay? That was our addition of